work from there. So, I mean, you two were here first. Do you have any specific questions that you want to go over? Or just kind of want to learn, just want to hear what everyone else is doing?
I guess that question in class, I might need to pull it up, about like...
about the debt?
Yeah.
Yeah, I know he's talking about the debt burden question.
The one that he did at the very end.
And I was like, that ball.
No, we're definitely going to go over that one.
Okay, cool.
That one we'll go over when everyone's here, like at 6:15 or 6:30.
Okay.
Just because I don't want to do it twice. Because I know you guys aren't the only ones who didn't know it. So do you guys have any specific questions, or just?
I don't really have any specific questions.
It's more useful when there are, but like I can sort of go over the main concepts without specific questions.
Do those those equations you like putting into each other, do you have to really know that? Can you just know like the concept of like if taxes or like if government spending increases, like your expenditure line's gonna increase, and it's like can you know that? You have to know like plug in.
My guess is you're not gonna have to know all that what he did, but you are gonna have to know that form. You are gonna have to know C equals A plus B disposable income, or A.
Yeah, okay.
So, but I don't think you'll have to like go through and like replug it in and find all that stuff. I think it's just easier for people, like he said, for people who think mathematically.
Okay.
It's easier for them.
Okay.
I can't imagine him doing anything too complicated algebra. Are you guys good with Open's law and how to apply it?
Is that the 2 percentage points that you have recently?
Sure. So the basic rule of
yeah, that's a good one.
yes. Okay. So the basic idea is 1% unemployment. Can you just sign in and grab one of those sheets? 1% unemployment will result in a 2% change in GDP output, etc., etc., etc. So, and they're opposite. So, a 1% increase in unemployment will cause a 2% decrease in GDP. So that's the basic idea. That's just like you should be able to know that cold, because that's what you have to know. That's what you have to memorize to be able to figure out the problem that he's going to ask. But there's a lot of different ways he can ask this problem. Did you, by any chance, look at the review test that he put up yet?
No.
Okay. So there's one question on there that there's at least one question on there that you have to do this. It's one of the short answer ones. So you're not going to get any short answers, but it's good to know the concept. Basically, what he does is he asks you to calculate the output gap. So he'll give you an equation for consumption, a potential GDP, potential output, government expenditure, taxes, all of the things you need to calculate what the GDP is currently and what the GDP should be, what the potential GDP is, and he'll ask you to calculate the output gap, and then how could you fill the output gap? So, increase spending by this much, or increase tax, or decrease taxes by this much. All those different things. Okay, can you grab a sheet and sign in, please?
Is that Open's?
This is Open's law, yes. Yeah. So
1% increase
in unemployment will result in a 2% decrease in GDP, and vice versa. So a 1% decrease in unemployment will result in a 2% increase in GDP. And so once you calculate the output gap, he can then ask you how much cyclical unemployment is there. Go for it. No. But please, if you guys feel like you want to jump in, that's great, because I love it when you guys can supply the explanation as well. But basically, you would calculate output gap. What percentage of potential GDP is that? So if the output gap is 200 and potential GDP is 1,000, 200 over 1,000 is 20%, so it's a 20% output gap. And then if there's a 20% output gap, you know that there is 10% cyclical unemployment, or 10% increase in unemployment from the natural. I'm getting blanks there. Yeah, I'm getting blanks there. I will put some numbers up here, but we'll make it a little bit easier. Sorry, my handwriting is so hideous. So here's your normal consumption. This is normally what you get, and then he'll also give you T equals 5 and G equals 6, and net exports equals 2. And potential GDP, so Y star is equal to, is everyone good with these abbreviations? Everyone know what potential GDP is, etc., etc. Net exports, good with that?
And the last one.
This is the potential. Yeah, equilibrium potential, same concept. So basically, he would say, here's the potential GDP. Find what the actual GDP is. So you know that GDP or income or anything like that is equal to C plus I plus G plus X, right? I forgot to put in I. If he doesn't give you an I, then give you an I. So you just calculate that. So Y equals, plug in C, 10 plus, and I'm going to separate these out just for simplicity's sake. You'll see in a bit. 0.5 Y minus 0.5 T plus G is 6, and net export is 2. So again, everyone good with this? How to get here? I just plugged in here and I distributed this 0.5. This, by the way, does anyone know what that is? What that 0.5 is?
MPC.
Exactly. So again, so he might give you this and say, what's the MPC? And you just know that is it. So the reason I separated these out is because you can see this is the same variable as this. So you would do this just like any other algebra problem. You subtract 0.5 y from both sides, and you get 0.5 y is equal to 10 plus 6 is 16 plus 2 is 18 minus 0.5 t. So 0.5 t is 2, so minus 2 from the 18 is 16. So currently, half of your GDP is 16. So you know that currently your economy is producing 32 units, $32. Your GDP is 32. Everyone good with that?
Wait, I is what?
I is investment, and I just forgot to put it in here.
Wait, so why do you put it? How do you get 0.5 y for it?
This term right here is all this. I just distributed this so that we could subtract the 0.5 y to the other side. Normally, yeah, you're right. He would give you an I also. He would give you I equals 2, but I just forgot to add it in there.
So that's another 0.5 t.
0.5 t. So t is equal to, I can use 4.
Oh, okay.
Yeah, and so it ends up being a negative 2. Cancels out 6 plus 10 is 16. 0.5 y is equal to 16, so y is equal to 2. So
wait, this t cancel out?
T is equal to 4.
Yeah.
So,
okay, you just plug in the 4.
Yeah.
Oh, and then where did you get the time? Is that just like?
I just made this problem up, which is why you're going to notice there's a huge positive output gap, which probably won't happen. That's what I made it. Okay, this is.
So what does the time represent?
This is autonomous spending. So this 10 is part of how you calculate consumption. So and it goes back to the equation we talked about at the beginning of class when we weren't here. It's just the C equals A plus MPC times disposable income. So autonomous spending plus MPC times Y minus 2, which is what was given up there. Good.
Wait, so did you just skip I?
Yeah.
Yeah. Because I forgot to put, when I was writing the parameters of the problem, I forgot to write normally he won't do that, but again, like you can calculate this without having a piece of it. He could say, oh, you're in a closed. If he says you're in a closed economy, it means that there's no exports. It means that you're just working within your own boundaries. So he could easily eliminate any one of the variables.
Could he put net exports and then say you're in the closed economy and then
I don't know if he will. My previous professor I taught for it did.
What's that? What's the concept again?
So net exports, you're assuming that you are importing and exporting material. But if you say you're in a closed economy, it means there's no. The definition is there are no exports. So that would just be kind of misleading. For those who walked in late, we're basically doing either the first or the second short answer on the review, but not with the right number. So now we've got current GDP and we've got potential GDP. So to get the output gap, you subtract a 1 from the other. So again, easy enough. 32 minus 20, output gap is equal to 12. And you need to know, you kind of need to, you can always mess with the positive negatives, but basically you need to know it's 12 and it's positive because the what you're actually producing at right now is bigger than your potential. So you need to know that. That's just kind of something.
You need to know what?
You need to know whether you do potential or whether you do real minus potential or potential minus real. You need to know, are you under potential or are you over potential?
So which one's your potential? The 20? Okay, and that's right. Okay.
So this is the output gap right now. It's a positive 12. And then you just want to find this is when you use Oken's law, or this is almost when you use Oken's law. So you need to figure out what is unemployment at compared to its natural rate. So whatever let's say the natural rate was 7%. So U star. So again, this star is it just means potential, normal, equilibrium, whatever the absolute normal is. So potential GDP, and then I guess you could also say potential unemployment is equal to 7%. So when you are producing 20 units of whatever we're doing, you have 7% unemployment. Just a warning, these numbers are about to get funky. I didn't do this. It's not perfect. But essentially, so the output gap is 12, and you need to figure out what percentage is the output gap of the potential. So you just do 12 over 20, and you get like 62%.
Wait, why are you doing that?
So you need to figure out, this is output gap, and this is Y star. You need to figure out what percentage your output gap is of your potential GDP, because this all relates back to Oken's law. So you're trying to figure this out right now. So you're trying to figure out what is the percentage change of GDP, so that I can figure out the percentage change in unemployment. You good? Yeah, blanks there. At least one. So this is 10 is 50 to 10. So this is 60%. So you're currently working 60% higher than your potential GDP. So you know that for every 2% of change in GDP, you've got a 1% change in unemployment, right? So if GDP is up 60%, then what effect is that on unemployment? Exactly. Like I said, these numbers are funky. And that is how he might ask you to apply Oken's law.
You know how like you got positive 12? Wouldn't that be a negative 12? But you don't have to write negative 12.
You can do it either way.
Okay.
Generally, you do potential minus real. So yes, you would get a negative 12.
Okay.
But the more important thing than doing it one way or the other is that you know, is it above or below potential. As long as you can keep straight in your head whether it's above or below potential, You'll know in the end. So if you were to do this negative and then kind of forget that this was above, and then you got to the end and you realized that unemployment was going up 30%, you would have to know that you have to reverse your sign, because obviously unemployment is not going up when you're above.
Okay.
Did anyone else want to ask any questions about this?
Yeah.
So looking at these equations for chapter 11, I'm confused by somebody, like, why do you need to do the 1 minus? Isn't that the multiply?
This is not this.
Yeah.
This is stemming from the equation he did today briefly on the board, and it's just
Yeah, I was
another
just
step
confused
farther.
why
Why
the
1 minus b?
because that's not what I wrote down in class, so that's why I was just.
I have to look at this.
Alright, well, it's not. This doesn't matter.
Yeah, what I can do is I can look at this if we run out of time, if we run out of questions today, or I can look at it if we run out of questions, or if not, what I can do is look at it tonight and then send you an email.
Okay, cool.
Does anyone have any other questions about this before I erase?
That's like that'd be like one of the only applications of using Open's law.
I mean, this is the most complex.
Okay.
So he might ask you directly, there's a 2% increase in unemployment. What is the change in GDP?
Oh yeah. Alright, so this is like the hardest scenario. Okay.
So if you can do this,
That
you
would be
can.
4%.
This would be yes, exactly.
Okay.
Sorry,
Yeah.
I was moving somewhere else. But yeah, if you can do this, you can do pretty much anything with Open's law. So, do you guys have any other specific questions, or any specific questions? Considering I just kind of went on a tangent there with Open's law. Do you guys have any specific questions that have come up since you started studying?
Yeah, can you go through the whole multiplier thing?
Just the concept
Yeah,
of the
just the
multiplier?
concept.
Sure. So, the idea behind the multiplier is that when more money enters the system, it doesn't just enter it once. It doesn't just get, if someone gives you $1 and you spend that dollar gets spent more than just once. So the entity that's usually bringing money into the economy is the government. So if the government spends $1 billion more 1 year than the previous year, obviously GDP goes up by $1 billion at first. But then that $1 billion is spent at a contractor. So they contracted somebody to build a new dam, and they paid them $1 billion that they hadn't been paying them. So that's $1 billion in GDP that's gone up. Production, good. That's all good stuff. Then the owner of the dam building business now has $1 billion more. Well, he's not just going to sit on it. He's not going to put it under his mattress. He's going to put some of it in his bank account. So let's say if we say the MPC, the marginal propensity to consume, is equal to 0.6. That means that for every dollar people in the economy have, they will spend 60 cents. And the other 40 cents they'll save for a rainy day, for the kids going to college, etc., whatever. So this dam business owner, now has $1 billion more. So he's going to put $400,000 into his bank account. It's going to be lent out to someone else to stimulate. He's going to save it for later, earn interest. And the other $600,000, he's going to go down to the store and he's going to buy $600,000 worth of packs of gum. I don't know. And so now the $1 billion that the government originally spent is now raised GDP by $1 billion when he first spent it, and then when the dam owner spent his portion, it's now gone up by $600,000 more. Now the owner of this gum store now has $600,000 more, and he's going to spend 60% of that at the next store. And it keeps going down the line like that until you get all the way down to the bottom when you have, and so each time the $1 billion that was originally spent is having a greater and greater impact on the economy. And so in the end, the multiplier, which is the multiplier is equal to 1 over 1 minus NPC, you'll get whatever you get here, that will be, you multiply that by the total amount spent in the beginning.
Yeah.
And you will, you get you to sign in and fill out a sheet. Yeah, more. You will get the total amount of difference that the original amount, the original $1 billion. So in this one, 1 over 1 minus 0.6 equals 1 over 0.4, which is 2.5. So if the government, assuming that the MPC is 0.6 and not counting in stabilizers, you will get $1 billion extra expenditure will raise the GDP by $2.5 billion. Okay. Everyone good on that? This is the concept of multipliers. Yes.
So this is with government specifically, that multiplier, and then if it taxes, it's negative MPC over that, right? Okay.
The tax multiplier is equal to negative MPC over 1 minus MPC. He's going. If you look in your notes or look on his PowerPoint, he goes over exactly how to get that. But you don't need to know it. It's helpful to know it. Just kind of be familiar with the concept. But the bottom line is tax multiplier is negative MPC over 1 minus MPC. So having this negative up here means that when there's a negative change in taxes, there's a positive multiplier. There's a positive effect on the GDP. And when there's a positive increase in taxes, there's a negative effect, which makes sense.
Could we go over the consumption income line?
Yes. Yeah. I'm gonna finish. Let's make sure. Are there any other questions on this? Or are you guys good with automatic stabilizers?
Are those taxing transfers?
Sort of.
But
They can be.
Those are things that don't have to go through a process to be.
They automatically kick in essentially. And what it is it's a automatic stabilizer is something that works against the multiplier, and it automatically goes into effect. I wish I had a good example. I don't. I've been looking because I had this conversation with someone on Sunday. I cannot find a good example of an automatic stabilizer. But the essential concept is it's something in the economy, whether it's through the government or not, that diminishes the effect of the multiplier. So NPC might be 0.6, therefore the multiplier might be 2.5. But when you spend $1 billion, you may only see a $2 billion increase in GDP. That half $1 billion loss that you were expecting is coming from the automatic stabilizer.
Could be like a mushroom tax or something, like you spend so much money and then it goes downhill.
Like yes, that's a good example. Income tax, because income tax is prorated, meaning that, or it's progressive, meaning that the bottom echelon of incomes get taxed at a lower percentage than the upper echelons. So if the government spends $1 billion and then the dam owner used to be in the middle echelon and now gets moved up to the top echelon, he's now paying more taxes than he used to be, right? Because he's now paying 20% as opposed to 18%. That will cause him to spend less because he's giving more to taxes, which will diminish the amount of the multiplier.
So the shift is the automatic.
That is one automatic. Yes.
So what kind of problems would he have with stabilizer?
I mean, they're all multiple choice questions, so he won't ask you to do any math. He'll ask something to the effect of, the automatic stabilizer is, he'll probably ask you, it'll probably be an answer for multiple choice, and it'll still say, what is the term for this when it does this, this, and this, and when it decreases the multiplier by 0.5%. And you'll know that that's an automatic stabilizer. And then an automatic destabilizer is the exact opposite. Something in the economy that makes the multiplier be larger than you expect it to be.
Do you have an example of this?
Not a good one. I can probably think of an example. So let's say you've been saving up for a new car. And you've been saving and saving, then suddenly government slashes taxes and you get a major rebate. Well, your normal MPC was 0.6. So normally, if you get $100 rebate, you'll spend 60 and save 40, right? But let's say you were $100 short of your car. You might take that $100 rebate and immediately spend it, all of it. So it'll have a bigger effect than you expected. I should just sign in and fill out one of those sheets. So that's an example. That's really not a great example of an automatic stabilizer, but it gets the point across. Any other questions? Alright, I'll erase this and we can always come back to it. So consumption and income line.
You want two address? Two address?
What address? No one's gonna contact you there. Which one is the consumption and income line? Because that is
that's like the relationship between consumption and income, or net taxes over the consumption and income line. And disposable
not
it says it uses real income, not disposable.
someone can draw on board. Do you have it in your notes?
Wait, I thought it was.
I just wrote it down.
There's a consumption line. I thought the consumption line was
So there's
the
a
disposable, and then the aggregated expenditure was.
Are we talking? So there's a couple lines that this kind of fits. Is it disposable income? That's not right. Thank you. Disposable income. Again, consumption. This one. So. Okay.
So zero.
Well, it's exactly. So what this line tells you, it gives you the relationship between how much people are consuming and how much income they're getting. So, but it tells you a number of things. So the first thing it tells you is the slope of this line is equal to MPC. So you know that if MPC changes, you'll find that the slope of the line changes. And then it also tells you this. When here is this is autonomous spending. So if the entire economy has zero disposable income, nobody has any extra money, they're only buying the absolute necessities, this is how much income, this is how much people are going to consume. You will never fall lower than that unless people are starving. Can we go with that? That's essentially what this line tells you. It adjusts with government spending and taxes and such because of it adjusts with taxes because disposable income is equal to income minus taxes. So if taxes were to increase, your disposable income would decrease, and you would find this line. The line wouldn't be lower. You would move along the line this way. Whereas government expenditures would increase the amount of money in the economy, and so somebody's income is increased because the government takes money and spends it at some sort of contractor. They're doing something with the money. They're not just throwing it out there. It's going to somebody, and it's becoming somebody's income, and it eventually becomes everybody's income through the multiplier effect through that process. And so that will increase everyone's income. You move that.
So what makes the line shift up and down?
A change in autonomous spending. So if people stop eating as much expensive red meat and they switch to cheaper alternatives like tofu, that would lower the autonomous spending because suddenly people are spending less money to get along with the very bare necessities.
Couldn't you just say like anything outside taxes, the change in taxes would affect the graph up and down, whereas taxes is the only thing.
We also, because an increase in government spending would in the long term, eventually, an increase in government spending would actually increase income.
Alright, so income impacts too. Then everything else like that.
Yeah, will affect either this or it will affect the slope of this. I don't think he's not going to ask you like something really esoteric, like how does an increase in investment change this? He's not asking that. Yeah. Did I answer your general question about this line?
Yeah. What kind of question would be asked? I just add the word there.
My guess is they'll either ask you something about a change, or give you this graph and they'll say, how would a change in, you can go about this question two ways, and there's probably two questions he'd ask you. He'll either ask you, how does a change in taxes affect this line? Or how does a change in autonomous spending affect this line? Or he might go about it in the reverse way. He might draw this line and then go like this. And then ask you, what kind of change would have caused you to move from M to M stuff? An increase in autonomous spending, exactly.
So,
This is the assumption.
so what's the difference in this one and the aggregate expenditure one? They're not the same?
They are very similar.
Okay.
They're not the same. So
Is it the same as the subscription?
they look very similar, and they are derived in the same way. And they're basically, this is the same line. You'll find this line again, but these axes are going to be slightly. So this is called the Keynesian cross, and this is aggregate expenditures, or just expenditures, versus income. And one thing, just don't be confused. On this bottom, it can be income, it can be Y, it can be GDP, it can be production even. I don't think they'll do that, but all of these things are equivalent in this scenario. So what you have is you have your 45-degree line, which is just a reference. It's there so that you can see where the normal equilibrium should be. And then you have your aggregate expenditures line. So this is aggregate expenditure, which is equal to C plus I plus G plus NX. So what we went over briefly in class today was basically, here's your equilibrium price, or equilibrium status. And basically what you're saying is, this is your level of spending, and it is equal to the level of expenditures, because you're on the 45-degree line, and every point on the 45-degree line has equal income to expenditures. Everyone with that? Again, that makes sense, 45-degree line, etc., etc. So, but in theory, you can be functioning here or here. It just means you're not in equilibrium. So if you're functioning here, as you can see, your expenditures, the amount of money that you're spending, is higher than your income. So people are out there spending, but they're not necessarily producing as much, which means you're cutting into your inventories. So if you always had an inventory of 50 widgets because you always want to make sure you have enough, suddenly you're going to be selling out of inventory because you're not employing enough people, you're not producing enough to meet the demand. And then the opposite. Good. Sorry, that was kind of quick. Does that make sense?
Okay, so you can't function on the 45-degree line below the equilibrium?
You always.
Or the aggregate expenditure.
Oh wow, I'm sorry. This should not be here.
Yeah, okay.
Good catch. This is here. My fault. You will always be, your economy is always on the aggregate expenditure line. And your equilibrium is where it intersects with this. But no, you cannot function on the 45-degree line. It's imaginary. So, in this one, this is the opposite situation. You're here, you're spending less than you're producing, which means you're building up inventories. If you're a business owner, you're producing a lot, and you still have your full factory working at full production, but suddenly you're not selling as much. People aren't spending at your store.
So that on this line, government increases, it'll shift this line, but not the other one.
Yeah, exactly.
Okay.
Any change in any of those will shift this up or down.
Okay.
And the slope of this one again, though, is MVC.
It's always best to be.
Yes. It's always best to be, and it's also where you will tend to be, because that's the other way. Know this one. I have a feeling I would bet that this one will be on. That's quite a bit. He likes this one, and it's very important. You need to know it for the next. You need to know it for the next couple chapters.
Can you find the short-term output?
Short-term output.
Question
number 3.
Or
4. So here's the question: in macro land, autonomous consumption. Actually, what is it, right? Yeah. I mean, is everyone good with this?
Mm-hmm.
You want to read it to me, and I'll write down the important parts?
Yes. Alright, macro autonomous consumption is 100. The MPC is 0.75. Taxes are 40. Planned investments 50. Government purchases are 150. And net exports are 20. And you find the short run equilibrium output.
Short run equilibrium output is just a fancy way of saying GDP, income, whatever you want. It is still just short run equilibrium output is equal to GDP is equal to Y, which is equal to C plus I plus G plus NX. You want to go from here?
Was that 0.25 to the MPC?
0.75.
Sometimes.
Like I said,
Yeah, I guess this is where I'm confused. How do you find consumption?
This goes back to the equation we were talking about at the very beginning that you have to know. You have to know that consumption is equal to autonomous consumption plus MPC times income minus taxes. Absolutely have to know it. There's no getting around it. Gotta know that equation. Full box of chalk. So, what do I do next?
Well, you know autonomous consumption, so you can put that in. And just plug in what you have. And then, but then you're missing Y. So, no, you're not.
We did when we were doing the Oken's law problem. And as soon as anyone who's good at math, good with the equations, you'll see exactly what you need to do quickly. Otherwise, I'll show it. But basically,
Can you just do the same thing you did?
it's exactly what you did on the Oken's law. You have to get both your y's on the same side. So first, you were right. First thing you do is plug in all your everything you know. So y is equal to autonomous or consumption, which is autonomous consumption plus, and here I'm going to split up this term. I'm going to make it MPC times y minus MPC MPC times 2. So we know MPC is 0.75, so plus 0.75y minus 0.75 t is 40. So there's autonomous consumption. No, this is all consumption. This is consumption plus investment, which is 50, plus government expenditures, which is 150. What were net exports?
20.
20. I don't know how I. Yeah, but anyway, plus net exports, which is 20. So, as you can see, it's just a normal algebra problem. You have y, bringing this y to the side, and
So you, oh, you will find both.
just well, this is the only variable that's left.
Okay, cool.
You guys want me to go through the math or not bother? Come on. What next? What would you guys like to cover? For those of you who have looked at the review, are there any other ones that you were looking at?
You want to do that depth one? That version
Yes, that is what I want to do. It's always so I can recall the numbers. Do you you want to pull it up? That'd be great. It's GDP here. And then
Was that chapter 12?
yes. Yes, it is.
Okay.
And
What years do you want? Do all of them? What numbers do you want? Like there's like 4.
yeah, that's where should we just let's put them all together? Yeah, let's put them all
Alright.
together.
So 10,000 billion.
10,000 billion. Okay.
Yeah.
I'm gonna
Yeah.
assume everything is in billions.
Okay.
So it's 10, then 11, then 12.
11 and then 12,100 and then 13,310.
Great. And then this is
5,000, 6,000, 7,200, 8,640. And then 50%, 54.5, 59.5, and 65. And 400 billion, 480, 576, 691.2. 4%, 4.4, 4.8, and 5.2.
okay. So before we go over what he was talking about, I want to make sure everyone understands what we have going on in this graph. So essentially, what we have is we have growth in GDP. It's growing at 10%. So 10,000. That's easy enough. Here we have debt, and this is growing at 20% per year. So from 5,000 to 6,000, etc., etc. So obviously, percentage-wise, debt is growing faster than. That's easy enough to recognize. Debt ratio goes along with that. Obviously, must also be increasing because the amount of debt to GDP is increasing because debt is increasing at a faster rate. Everyone go with that? So then what we have here is interest rate. So this is 8% of this. And that is growing because you're paying a percentage of the debt you have out, and the amount of debt you have is increasing. And then lastly, we have debt burden, which does it have exactly how it's calculated on there? What is it?
Column 4 divided by column 1.
So basically, this debt burden is how much taxpayers are paying. So it's the amount of interest you're paying divided by the amount of production you're having. So as a percentage, how much of what you produce is going to paying just the interest, just the service fee. That's what they call it. It's paying just the interest. So as you can see, this country would have a pretty big problem in that they are rapidly growing the percentage of debt that they have, and B, they're putting a larger and larger burden on their taxpayers. So let's say we're going to say we're here. This is the type of problem he said he's probably going to get. You see this, 4, 4.8, 4, 4, 4.8. Let's say you're here, you're in this year, and the government has decided we are not going to have a debt burden. The debt burden is going to be the same size, exactly the same size. We want debt burden to be 4.8. I wish I had another color chart. So obviously, if you want this to happen, all of these numbers have to be there, except GDP. We're assuming he said that in this type of problem, you're going to assume that you're growing your GDP at the fastest rate you can. Nothing you can do about that. It's going to stay constant. So you know this. You know what is the debt burden you want to have. Debt burden is a percentage of your full GDP, right? We just talked about that. So you need to figure out what this is. The way you do that is you would simply multiply 4.8 by 13.3. This one have a calculator. You will need a calculator for this problem, without a doubt. Yeah, 0.048.
638.88.
So by saying that you want a debt burden no bigger than 4.8%, you're saying that you do not want to be paying more than $638 billion in interest. Will not pay anybody. What was the previous number? It was 650? 676.
What's the which one? Okay, that goes 691.
Alright, just making sure that the check. Just a really quick check for yourself. If this number decreases, this number better also decrease. Obviously, I mean it's pretty self-explanatory, but like it's just a good way to check to make sure that you're moving in the right direction. So now you know your interest rate. You know you want to pay $638 worth of $1 billion. So that from there you need to figure out what your debt is. So to get this number, normally you multiply this times 8% to get this. So to go in the opposite direction, you just divide 638.9 by 8%. Does that make sense? You are just taking your 8% rate. You know that this is 8% of something, so So if you divide it by 8%, you get whatever that something is. The
So how
number
did
is
you find debt, like, in the columns? You multiply?
in the column. What do you
Like, in the second column, you said you would multiply what? Your interest rate?
To move from debt to interest rate, you multiply total debt by 8%, or whatever the interest rate is. He may change the interest rate up.
Okay.
So to do the opposite, you just move in the opposite direction. Chris, what is that? Can you do this? Or sorry,
I'm writing them down. 638 for regular total. 7,906. That'd be great.
So, and this should be lower than the previous number. And so, which I hope it is.
Yep.
Good. And so now you know you didn't want a debt burden larger than 4.8, so you know you can't pay any more debt you can't pay any more interest other than 638. And if you want to pay $638 billion of interest, you need to have a debt of 7 trillion, or almost 8 trillion.
And your debt burden is just your total GDP.
Yes. No, it's interest.
The debt ratio.
Yep.
Yeah.
Oh, the debt ratio, yes, is just debt over GDP. Can we go with that?
That's definitely a good problem.
Definitely gonna be on that. Definitely fun.
So he's going to ask you, like, what? To find that one?
I don't know what he's gonna ask.
Okay.
Most likely, yeah, he's gonna do exactly what we just did. He's gonna say, we want our debt burden to be X. How much debt can we take on? And then he's gonna ask you, how much debt can you take on? And then he's probably gonna ask you to do this minus that. So in this fourth year, you can take on up to 700. You're gonna take on up to $786 billion. Yeah, he might also ask you what percentage growth. Well, I don't think he'll get this complex, but he might ask you not just what is the difference between these two, like how much debt can you take on, but what percent growth should it be? So from here to here and from here to here was 20% growth. Obviously, this is going to be less than 20% growth. He may ask you what percent growth, and then you just do this minus that over this. So this one's going to be a little bit more than 10%. Good. We have 10 minutes left in the session. Are there any other burning questions you guys have? If not, I guess I can. I have the topics that you need out. I can just read them off and ask if you guys have any doubts about any of the topics. We can just talk them through.
Real quick, I know you did this before I got here, but Oakland's law, could you quickly?
So Oakland's law, in its most basic form, is 1% change in unemployment results in a 2% change in GDP.
Okay.
So a 1% increase in unemployment would result in a 2% decrease in GDP, and vice versa. And the way he would usually apply that is he may give you how to calculate a GDP, give you all the components, and then ask you, if this is the potential and this is what you currently are at, what's the output gap? And then using Oakland's law, and which he may not say, he may just ask you, he'll give you the natural unemployment rate and say, how much higher is it than this? Or what's the current unemployment rate? And you'll know if the output gap is 10% of potential GDP, you'll know that there's a 5% increase in it.
The output gap, like,
Difference between potential and real. So chapter 10 is business cycles and Oakland's law. I'm going to go to business cycles. Chapter 11 is short-run macro model, which is the stuff. I mean, this whole thing is sort of a macro model. And aggregate expenditure, we did. MPC and multiplier, we did. Finding equilibria, again, where the lines cross. That's where the equilibrium is going to be. The Keynesian cross, we did that. That was the. Yes, that's the 45. And fiscal policy. Anyone know what that means? What is fiscal policy? Government expenditure. Yeah. How much does the government spend? It's not monetary policy, but I don't think you can ask me anything about monetary policy. And then chapter 12 is government expenditures and taxes, and then debt. We just did that. That was that last. No, that was the last one. The debt burden.
What's the type of question you asked us?
I mean, you generally have to know it. I don't know if he'll ask any specific questions about it. He might ask something very basic, just like the government decides to pass a bill that releases $1 billion into the economy for public works. What type of policy is it? Fiscal, monetary, criminal, contract. That's It's that's the most basic I can think of. I don't know if he'll ask you a specific question. You just kind of need to know the concept of what is fiscal policy.
Another question. On the homework question, there was a few where you used examples from like specific time periods. Like in 2008, the government did this. Is that going to be the one or the first time?
My guess is yes, but I don't think he's not gonna make you know. Like he's not gonna say in 2008 what happened.
Yeah.
But he might tell you, oh, this happened in this era. What does that result in, or what does it mean, or what could have caused this? That's my guess. I didn't have him, so I don't know. But
I'm sure he'll talk about the oil shock.
yeah, wouldn't surprise me. I don't think he'll ask you anything like what happened in the oil shock.
Yeah.
But and that's a third of macro in an hour.
Wait.
Thank you.
Thank you.
Sure. You guys have any individual questions you want to ask? I still got 10 or so minutes here.